So as I said in the preceding video, that this system, we can either solve it by substitution, that I did it in the preceding system, and now we're gonna do it by elimination. When I say elimination, it means I need to think about which variable I want to eliminate. And this variable that I will eliminate, I need to eliminate it together from the first two equations and then from the second two equations. When I add the first two equations, I will get another equation. And then when I eliminate the second two equations, I will get another equation. And those two equations that I got here will form for me a new system. So let's do it together. I look at those two equations and I thought that I want to eliminate y. Since I want to eliminate y when I'm adding those two equations, the only way is to do that is by multiplying the first equation by 2 to have opposite coefficient for y. Here it's y, here is minus 2y, so I want it to be 2y. So the first equation becomes 4x plus 2y minus 2z is equal to 10. The second equation is already as it is, x minus 2y minus 3z minus 0. We add it together and I got an equation in terms of x and z. So what I need to do with the other two equations in the middle and the last one, also I need to eliminate y to have another equation in terms of x and z to be able to form a system with just two variables and to solve it. So what I did, I multiplied the last equation by minus 2 to have opposite coefficient for y. I got x minus y minus 3 is equal to 0. It's the same for the second one. Minus 10x plus 2y minus 4z is equal to minus 2. When you add, I have another equation in terms of x and z. And now I can form a new system of two variables with x and z. And I need to do the same also. I need to solve it by elimination. But I noticed that I can divide by 5 to make this equation more simple. So I got x minus z is equal to 2. And then I multiplied it by 9 to have opposite coefficient for x. The first equation here, this equation becomes 9x minus 9z is equal to 2, is equal to 18, sorry. The second one is already here, minus 9x minus 7z is equal to minus 2. When you add those two equations, I got z first, it's minus 1. I got z. How are we gonna find x and y? It's easy. I will replace that here by minus 1. Once I get x, I will replace it in the first equation and I will get the three variables. So I replaced here z by minus 1. I got x. And then I replace it all x and z. In the first equation, I will get y, and then I have the same solution 1, 2, minus 1. On purpose, I used the same system to show you that either if you solve it by substitution or elimination, you will get the same answer. Now let's move to the last part in this lesson, is how do we do it with row reduction using matrices. I will write the system as a matrix. So the first column represents x, y, z, and this is the constant. So I just copy it as it is. Look at it. 2, 1, minus 1, 5. 1 minus 2 minus 3, 0. 5 minus 1, 2, 1. The objective of this method is the circles want to become 0. Sure, it's easier if I do this line also 1, but even if you didn't have it 1, you can solve it. The most important part is to change those three variables to be 0. Why? Because once those are 0, this is z. Z is equal to the constant, I have it. Then I will get z. Here we'll have y and z is equal to a constant. So when you replace z by the value that you got, you will have y. You have y and you replace it here, you will have x. So sure, you can also change the 2 minus 2 to those to be 1. It's an extra part or an extra step, but the main objective is to change those three that I circled here 0. How are we gonna do this? By elimination, sure. First, I would think about changing the 5 to 0. How I will make this 5 0? I need to subtract it with one of those two lines, with one of those two rows. So what I need to do is to multiply this one by 5 and subtract it from this one. But when you multiply this by 5, you don't write the multiplication here. No, I'm just replacing the third line. The third line, I want to replace it by 5 times R2 minus R3. That's it. I just replaced, I'll multiply it in my mind. So I will do it in my mind. 5 times 5, it's a 5 times 1, 5. 5 minus 5, 0. Then 5 times minus 2, minus 10, minus 10, minus 1, minus 10, plus 1, it's minus 9. 5 times minus 3, minus 15, minus 2, minus 17. 5 times 0, 0 minus 1, it's minus 1. So now have the last row here. I have this 0. I still have to do two things. I need to make those two zeros. Now I'm focusing on making this one 0. By which I will use which line? I will use the first one. The 2, it should be 1, and if I subtract it becomes 0. So what I will do is the first row R1, I will make R1 over 2 minus R2. So also mentally I will do it all on the calculator. 2 over 2, 1. 1 minus 1, 0. But 1 over 2 minus 2, it means 1 over 2 plus 2. If you do the same denominator, you will have 1 over 2 plus 4 over 2, so it's 5 over 2. Minus 2 over 1, minus half, plus a 3 over 2, because minus minus, so also it's 5 over 2. And here I will have 5 over 2 minus 0, 5 over 2. So now I have, this is 0, this is 0, I'm safe. I can multiply all this row by 2. Why? To make it without any fraction. I think in the beginning of the video I said instead of columns, I read the columns, I said row by mistake. Now I noticed that. So no, we write the columns, those are the columns and those are the rows. Now let's continue. So I will get 2, 1, minus 1, 5, 0, 5, 5, 5, and 0, minus 9, minus 17, minus 1. Also, I can make this row more simple if you divide it by 5. So I will have 0, 1, 1, 1. Again, I still have one objective. This one is bothering me. I want it to be 0. So what I will do, I will multiply, yani I will replace the last row by 9 times R2 plus R3. 9 times 1, 9, minus 9, 0. 9 times 1, 9, 9 minus 17, minus 18. 9 times 1, 9, 9 minus 1, it's 8. And also I can make it more simple by dividing by 8, and I got it like this. You can continue, I can continue my work to make this 2, 1 also if I want. I can divide all this by 2, for example. But you can do it this way. Now I can change the matrix to a system. And I will write my system again. So 2x plus y minus z is equal to 5. This is the first equation. The second equation, there's no x. Y plus z is equal to 1. The last equation, no x, no y, minus z is equal to 1. And now I will solve from down till up. Minus z is equal to minus 1. It means z is equal to minus 1. I got z. Now I replace it in the preceding equation. Y minus 1 is equal to 1, so y is equal to 2. Oh, excellent. I have z and I have y, and now I still have to find x. I will replace it in the first equation. 2x minus 1 plus 1, 2x plus 2 plus 1 is equal to 5. And then when I replace, I will get x, and I got exactly the same answer. I have 1, 2 minus 1. So you have 3 methods. You can use any method if they didn't precise for you which method to use. That's it for this lesson. Sure, we will do more application in the class. Hope you enjoyed the video. Don't forget to like, subscribe, and share. See you next time in another